Hello, everyone. My name is JJ Bennett. I'm a senior software engineer at UT Libraries, and today I'm going to do a brief presentation at just a high level about how we at UTL are using Fedora in our DAMS ecosystem. And a little more specifically, I'm going to be talking about our use of archival groups, events, or more accurately, our attempts at using Fedora internal messaging queues, the AMQ, and access control in our digital asset management system that we are currently building. So a little bit about us, UT Library's mission to advance teaching, catalyze research, and democratize learning in order to develop critical thinkers and global citizens. High level, a little bit about our infrastructure. We try to run the vast majority of our applications and projects in a containerized environment. So that means we use Docker, Kubernetes with a Rancher infrastructure. Some random statistics about some of our deployments, pods, and cron jobs that we all run on our Kubernetes infrastructure. And we currently use Harbor and GitHub Actions for continuous integration and continuous deployment. Let's go ahead and move on. So today we'll first go over a high-level overview of our new DAMS architecture that we've been working on for the past year and will continue to be working on this upcoming year. For purposes of this presentation, I will simply refer to it as DAMS. However, I do want to point out we're workshopping a more unique name for our ecosystem, and we do plan on open sourcing our DAMS solution once we've completed it. We'll then briefly discuss our use of archival groups in Fedora, our attempt to leverage Fedora's internal AMQ, and ultimately why we decided to abandon that, and how we are serving media files directly from Fedora using access control lists. So this is an oversimplified high-level view of our new DAMS architecture. This doesn't include some integrations, and it also does not include some future enhancements and additional integrations we plan on adding. So at a base level, you can see we're using a Python Django stack to design and implement our backend business logic. This backend interacts via API with Fedora 6, which is where the media files, IIIF manifests, and metadata.json files actually live. Representations of this data and references to the files are also stored in a Postgres database and internal Elasticsearch index. We found the implementation of Elasticsearch in particular to be a key piece in making our administrative portal functional. With the level of data we have, relying on database queries is just too slow, and reading directly from Fedora is even slower. By having the data represented in Elasticsearch, DAMS content managers are able to efficiently read and edit collections and assets. We have separate microservices for derivative generation. So when assets are ingested, we automatically generate derivative files that we can then use in our public front-facing portals. And depending on the type of media, files are served to our public portals via Wowza video streaming, a Cantaloupe image server, or through an Nginx proxy. Okay, so archival groups. Original problem requirement, we wanted to model repositories which contain collections, which contain assets, which contain files and metadata. We wanted it to be OCFL friendly and in that hierarchy. And what we ended up doing, or how we ended up mapping that hierarchy in Fedora, is we have top-level repository and collection containers. And then as far as archival groups go, we are using archival groups for the object level. So inside of a standard Fedora container that is a repository or a collection, in some cases we have nested collections. Where we're using archival groups is at the object level, or excuse me, at the asset object level. And then pages and files are stored as binaries within that archival group. In our system, collections serve as the primary organizational containers for assets, as I mentioned. So to group assets along with their associated files, we introduced archival groups. Within that archival group is the binary files, so the actual media files themselves, a metadata.json file, and a IIIF manifest. While this approach did make sense for us from an organizational standpoint, we also ran into some significant technical challenges. Specifically, we frequently encountered Fedora 409 errors because archival groups do not support modifying multiple binaries simultaneously. So that limitation became particularly apparent when our DAM system invoked the derivative generation microservice. Some binaries were not being created as expected, which would result in incomplete processing. That meant that we had to slow down some of our processing and really ensure that all the operations were performed synchronously. So in summary, we found that the use of archival groups made a lot of sense for us. It does give us predictable Fedora IDs and paths, and it does fit the conceptual model we use when we're thinking about the hierarchical structure of the content within our DAMs. That said, gotchas and lessons and takeaways, we learned that planning the Fedora hierarchy early on does matter. We've gone through several iterations and I found significant refactoring later down the road can be pretty painful. So to be transparent, we're still iterating on exactly how we want our data in the STAMS ecosystem to be represented in Fedora and how we want that to be structured. We've pivoted at several different points. Just to give one particular example, at one point we were storing taxonomies as separate data structures within Fedora, but we found that placed too many limitations on our ability to rapidly change that data. So what we ended up doing is keeping most of that logic in-house via Django and Postgres. It's simply much more convenient for all aspects of development. The final takeaway is that Fedora is good at what it's designed for, archiving. That said, at times we found that that ran counter to our goal of creating a DAMS that is optimized for rapid ingestion and curation of content. So as a result, as we iterated on this project, while we still rely on Fedora and OCFL as our backbone, we've shifted away from a Fedora first approach and instead rely on Django, Postgres, and Elasticsearch for a lot of the user-facing functionality. Speaking to how we pivoted away from what I've called a Fedora first approach, another example can be seen in our exploration of Fedora's internal AMQ messaging. As we've gone through this project, the order of operations and flow of data has gone through several iterations. Initially, we imagined that we might be able to use Fedora as the source of truth for events, and by so doing, avoid the complexity and conflicts that could arise from the implementation of our own Celery Redis-based queues and Django-based signals. That said, this attempt did present several challenges. The biggest was that it represented a shift in the way we had been considering the flow of data into and out of our DAMs. With our Python Django backend service as the primary controller for the system, existing processes had been set up accordingly. So we realized we need to significantly rethink and refactor our workflows in order to avoid conflicts or loops. For example, a Django signal firing off an update that would trigger a change in Fedora, which could then trigger a message to generate derivatives or perform some other task, which then in turn could fire off another Django signal or a Celery task. So we didn't want to end up in overcomplicated, over-engineered signal or messaging loops. Our squad also lacked familiarity with the AMQ framework, and we found some of the documentation to be lacking, which I will talk about more in the next slide. As a specific use case where we looked into using Fedora's internal messaging, we were hoping we could leverage it in our derivative generation process. But in addition to encountering some unexpected issues with using archival groups, the Fedora 409 errors that I mentioned earlier, the messaging queue had lackluster documentation and was challenging to reconfigure for our containerized environment. So a couple specific examples, the AMQ documentation didn't offer much information about the default configuration. neglected to mention some meaningful event types like purge, which is sent when an archival group is deleted, but different from delete, which is sent when any other object is deleted. Some events would also trigger messages with multiple types, such as both create and update firing at once. This made it difficult, for example, to discriminate between objects that were newly created and might need derivatives generated for the first time, or if we were just updating some metadata on an already existing object and didn't need to take any further action. So ultimately, we found that we could make AMQ work, but because everything we run is containerized, we did not want to use Fedora's internal AMQ since that would make it ephemeral. So we considered briefly hosting our own AMQ, but ultimately decided the easiest solution for us was simply going with our existing Celery Redis messaging. So takeaways, given the use case for DAMs, it was easier to implement messaging and signaling in our Django backend. Existing Celery Redis messaging was used. Our squad has familiarity and expertise in that tech stack. It does follow conceptually the flow of data better with DAMs as the central controller. And in summary, you could say, given a project that was more archival focused as opposed to rapid ingestion and curation focused, it would make more sense to use a Fedora first approach and leverage Fedora's internal messaging. Okay, access control list or ACL-based media serving. So the question we had to ask ourselves was, do we gate access in Fedora or do we gate access entirely in our Django app layer? Our current philosophy, and it's working well for us, is that Fedora ACLs are an enforcement layer, not an authorization brain. So our Django backend remains the authority. Fedora ACLs are a projection enforcing a cached version of that policy. Currently, media assets are served directly from Fedora, providing an authoritative source for digital objects. ACLs enforce granular permission control, aligning access with our institutional rules. We have a public user and an admin user. The public user has CRUD, or create, read, update, delete permissions, while the public user has only read permissions for specific objects that we consider published. So when an asset is saved, we check the ACL in Fedora and make sure it matches up with a published Boolean flag that our DAMS keeps track of. When an asset is successfully published to a public portal, this flag is flipped. When that happens, we make a call to Fedora to update the readability of files associated with that asset. We are using a custom default root ACL that also grants the public user permission to view any object tagged with a specific snippet of RDF metadata that says basically UTDAMS public. And since I mentioned RDF, I also wanted to mention that at this time we are not using RDF, we just tag assets with ACLs. So as I mentioned, public asset access, there are Wowza, Cantaloupe, and Nginx deployments that reverse proxy Fedora binaries using the public user. On public portals, we can only display the public Fedora assets. Then private access are administrative portal that our DAMS content managers use. To display those unpublished assets, the DAMS acts as a proxy to Fedora for audio, video, and downloads. And for Cantaloupe, there's a private Cantaloupe that has no public ingress, and our DAMS proxies authenticate through that private Cantaloupe. Finally, in summary, our takeaways. Fedora Archival Groups gave us a strong hierarchical backbone that matches our repository collection asset structure, but limits our ability to make concurrent changes, which does slow down some of our operations. Fedora's internal messaging via AMQ has a learning curve. We decided to abandon it to rely on Celery Redis queues we were already familiar with. And we are serving media files directly from Fedora thanks to ACLs, which allow us to provide a single authoritative source for all digital objects. And that brings us to the end of the presentation. I'm happy to answer questions. Here's my contact info if anyone has any follow-up questions, if you don't want to ask now, feel free to email me. Happy to answer those later as well.
Thank you so much.
Yeah.
Floor is open for questions. Yeah, Dorn.
Yeah, thanks for the presentation. A couple quick questions. One is, are you in the cloud or on-prem? And second, were you building these Fedora OCFL resources by hand, or did you migrate them from a previous version of Fedora? Thank you.
Yeah, we're on-prem. UT has its own data center, so I guess it's kind of in cloud but on-prem. It's our own cloud in a way. That's probably the best way to think of it. And yes, we built this from scratch. We did not migrate. We did have a previous implementation actually using Islandora and Fedora 3. We did not migrate directly from that to this system. We ran our own migration essentially. So we built this Fedora structure by hand.
All right. Thank you.
Yeah.
Yeah, Jaime.
Hey, Larry. Thank you so much for your presentation. It's very, very impressive. I've been following the work you've been doing since a couple Fedora virtual showcases already, and we kind of based our work also on the ideas you also presented. Thank you so much. I wanted to ask something about, I'm not sure if I understood it correctly. You use the ACL from Fedora. Do you set up like agents or different roles that you can where you can customize the access control for different type of agents, or how do you do that again?
So we have just a super simple setup right now, and it's just a public user and a private user, and it's just that one basically published, whether an asset is considered published or not, and that's all we're currently doing. Some of our like within the DAM's administrative portal itself, there's then levels of access that is just managed by the Django side of things.
All right. Thank you.
Yeah.
Thank you so much.
Yeah.
Awesome. Anybody else? Good questions. All right. Well, thank you. Thanks.